So far, we have learned a lot about how to develop backend web services with gRPC. When it comes to deployment, one important thing we should consider is load balancing. A large-scale gRPC deployment typically has a number of identical backend servers and a number of clients. Load balancing is used for distributing the load from clients optimally across available servers. There are two main options of gRPC load balancing: server-side and client-side. Deciding which one to use is a primary architectural choice. In server-side load balancing, the client uses RPC to the load balancer or proxy, such as Nginx or Envoy. The load balancer distributes the RPC calls to one of the available backend servers. It also keeps track of the load on each server and implements algorithms for distributing load fairly. The clients themselves do not know about the backend servers. In client-side load balancing, the client is aware of multiple backend servers and chooses one to use for each RPC. Usually, the backend servers register themselves with a service discovery infrastructure, such as console or etcd. Then the client communicates with that infrastructure to know the addresses of the servers. A thick client implements the load balancing algorithms itself. For example, in a simple configuration where server load is not considered, client can just route robin between available servers. Another approach is to use a looker-side load balancer, where the load balancing smarts are implemented in a special load balancing server. Clients query the looker-side load balancer to get the best servers to use. The heavy lifting of keeping server state, service discovery, and implementation of load balancing algorithm is consolidated in the looker-side load balancer. Let's look at some pros and cons of these approaches. One pro of the server-side load balancing is simple client implementation. All client needs to know is the address of the proxy. No more coding is needed. And this approach works even for untrusted clients, which means the gRPC service can be open for everyone from the public internet. However, its cons is adding one more extra hop to the core. All RPCs have to go through the proxy before reaching the backend servers, thus causing higher latency. Therefore, this server-side load balancing is suitable for the cases where there are many clients, possibly untrusted from the open internet, who wants to connect to our gRPC servers in the data center. The client-side load balancing, on the other hand, doesn't add any extra hop to the core, and thus giving us higher performance in general. However, the client implementation now becomes more complex, especially for thick client approach, and it should only be used for trusted clients, or we will need to use the looker-side load balancer to stand in the front of the trust boundary network. Because of those attributes, client-side load balancing is often used in a very high traffic system and microservices architecture. In this video, we will learn how to set up server-side load balancing for gRPC services with Nginx. Since I'm going to show you different Nginx configurations where TLS can be enabled or disabled on the server and client, let's update our code a bit to take in a new command line argument. This TLS argument is a Boolean flag, which will tell us whether we want to enable TLS on our gRPC server or not. The default value is false. Let's also add it to this log so we can see its value when the server starts. Then I will extract these interceptors to a separate server option variable. We have to move the interceptor object up here. Now we check the TLS flag. Only in case it's enabled, then we load the TLS credentials and append that credentials to the server option slice. Finally, we just pass the server options to the gRPC.newServer function call. And that's it for the server. Now let's do similar thing for the client. First, we add the TLS flag to the command line argument. Update this log message to include the TLS value. Then we define the transport option variable with the default value gRPC with insecure. Only when the TLS flag value is true, we load the TLS credentials from PEM files and change the transport option to gRPC with that TLS transport credentials. Finally, we pass the transport option to this gRPC connection, and this one as well. Now the client is done. We will have to update the make file a little bit to pass in the TLS flag. But first, let's try running the service without TLS. For now, if we run make server, we can see that the server is running with TLS disabled. And if we run make client, it's also running with no TLS. And all the RPC calls are successful. Now if we add this TLS flag to the server and restart it, the TLS will be enabled. If we run make client now, the request will fail. We have to enable TLS on client side as well by adding TLS flag to the make client command. And we can see the requests are successful again. Alright, now the TLS flag is working as we want. It's time to do some load balancing on our server. Let's start with insecure gRPC first. So I'm going to remove these TLS flags so that the make server and make client commands will run without TLS. And I will add 2 more make commands to run 2 instances of the server on different ports. Let's say the first server will run on port 551 and the second server will run on port 552. The next thing we need to do is to install Nginx. Since I'm on a Mac, I can simply use homebrew. So brew install Nginx. After Nginx is installed, we can go to this folder to configure it. In the user local etc Nginx folder, there's a Nginx config file. Let's open it with Visual Studio Code. This is the default configuration. There are several things that we don't need to care about in this tutorial. So I'm going to remove this user config and comment this error log. Remove the config for log levels and process ID. And let's say we just need 10 worker connections for now. One important thing we need to do is to configure the right location to store the error log and access log files. In my case, Homebrew has already created a log folder for Nginx at user local var log Nginx. So I just go ahead to copy the full path of this folder and paste it in this error log setting. This log format is also unnecessary for now. For the access log file, I will put it in the same location with the error log file. Next, we don't need all of these configs, so let's get rid of them. In the server block, we have a listen command to listen to incoming requests from client on port 8080. This is a default config for a normal HTTP server. Since gRPC uses HTTP2, we should add HTTP2 at the end of this command. Let's remove this server name and charset since we don't need them now. Similar for the access log because we've already defined it above. Let's delete this config for the default root HTML file and everything after this block as we don't care about them for now. Okay, now we want to load balance the incoming request to our 2 server instances. So we should define the upstream for them. I'm going to call it upstream PCBook services. And inside this block, we use a server keyword to declare a server instance. The first one is running on localhost port 551, and the second one is running on port 552. To route all RPC calls to the upstream, in this location block, we use the gRPC pass keyword, followed by the gRPC scheme and the name of the upstream, which is PCBook services. And that's it. The load balancing for our insecure gRPC server is done. Let's run Nginx in the terminal to start it. We can check if it's running or not using this ps and grep command. Let's check out the log folder. As you can see, two files are generated, access.log and error.log, and they are empty at the moment because we haven't sent any requests yet. Now let's run make server 1. Okay, it started on port 551 with TLS equals false. Then on another tab, we run make server 2. It's running on port 552, also with TLS disabled. Now let's run the client. Looks good, all RPC calls are successful. Let's check the logs on our servers. The server 2 receives 2 create laptop requests, and the server 1 receives 1 login request and 1 create laptop request. Excellent. And after a while, there's another login request coming to this server. That's because our client is still running and it periodically calls login to refresh the token. I hope you still remember the code that we've written in the gRPC interceptors lecture. Okay, now let's look at the Nginx access log file. You can see first there's a login call, then 3 create laptop calls, and finally another login call. So everything is working exactly as we expect. Next, I'm going to show you how to enable TOS for Nginx. In a typical deployment, the gRPC servers are already running inside a trusted network, and only the load balancer, or Nginx in this case, is exposed to the public internet. So we can leave our gRPC servers running without TOS as before, and only add the TOS to Nginx. To do that, we will need to copy 3 PEM files to the Nginx config folder: the server's certificate, the server's private key, and the certificate of the CA who signed client certificate if we want to use mutual TOS. Okay, so now I'm going to cd to the user local etc Nginx folder and create a new cert folder. Then I will copy those 3 PEM files from our PCBook project to this folder. Alright, now all the certificate and key files are ready. Let's add one more client TOS command to the make file to run the client with TOS. And go back to our Nginx config file. To enable TOS, we first need to add SSL to this listen command. Then we use the SSL certificate command to give Nginx the location of the server certificate file. And we use the SSL certificate key command to give it the location of the server's private key file. As we are using mutual TOS, we also need to use the SSL client certificate command to tell Nginx the location of the client CA certificate file. And finally, we set SSL verify client to on to tell Nginx to verify the authenticity of the certificate that client will send. And we are done. Let's restart Nginx. We run Nginx -s stop to stop it first. If we run ps command, Nginx is no longer running. Then we start it with Nginx command and check it again with ps command. 2 Nginx processes are running. One is the worker and the other is a master process. Our server is already running, so let's run the client. If we just run make client, it will run without TOS, so the request will fail because Nginx is now running with TOS enabled. Now let's run make client TOS. This time the client is running with TOS and all requests are successful. Keep in mind that our servers are still running without TLS. So basically what happened is, only the connection between client and Nginx is secure, and Nginx is connecting to our backend servers via another insecure connections. So once Nginx receives the encrypted data from client, it will decrypt the data before forwarding it to the backend servers. Therefore, you should only use this approach if the Nginx and backend servers stay in the same trusted network. But what if they are not on the same trusted network? Well, in that case, we have no choice but to enable TLS on our backend servers as well, and configure Nginx to work with it. Let's add two more make commands to start two server instances with TLS. The server1 TLS command will start TLS server on port 551, and the server2 TLS command will start another TLS server on port 552. Alright, let's stop the current server1 and start server1 with TLS. Similarly, I will stop the current server2 and start server2 with TLS. Now if we run make client TLS immediately, the request will fail. The reason is, although the TLS handshake between the client and Nginx succeeded, the TLS handshake between the Nginx and our backend servers failed. Since the backend servers are now expecting a secure TLS connection, while Nginx is still using insecure connection when connecting to the servers. As you can see in this error log, the failure happened when Nginx talked to the upstream servers. To enable TLS connection between Nginx and upstream servers, in the Nginx config file, we have to change this gRPC scheme to gRPCs. This should be enough if you use server-side TLS only. However, in this case, we are using mutual TLS. So if we just restart Nginx now and rerun the client TLS, the request still fails because Nginx is not configured to send its certificate to the upstream servers yet. So we've got the bad certificate error, as you can see in the error log. Let's see what happens if we go to the server code and change this client auth to no client cert, which means we will just use server-side TLS. Then restart server1 TLS, restart server2 TLS, and run make client TLS again. This time all requests are successful, exactly what we expected. Okay, now what if we really want mutual TLS between Nginx and upstream? Let's change this client auth back to require and verify client cert, and restart the two TLS backend servers. Get back to our Nginx config file. We must instruct Nginx to do mutual TLS with the backend servers by giving it the location of the certificate and private key. We use a gRPC SSL certificate for the certificate and the gRPC SSL certificate key for the private key file. You can generate a different pair of certificate and private key for Nginx if you want. Here I simply use the same certificate and private key of the servers. Okay, let's try it. First stop the current Nginx process, then start a new one, and run make client TLS again. This time all requests are successful. Perfect! There's one more thing I want to show you before we finish. As you've already seen, the login and create laptop requests are now evenly distributed between our two backend servers. But sometimes we might want to separate the authentication service and the business logic service. For example, let's say we want all login requests to go to the server 1 and all other requests to go to server 2. In that case, we can also tell Nginx to route the request based on its path. Here I just copy the path of the auth service and paste it to this location. Then I change this upstream name to auth services, and it should only connect to the server 1 at port 551. I'm going to add another upstream for the laptop services and make it only connect to server 2 at port 552. Then duplicate this location block. Change the upstream name to laptop services and update the path to techschool.pcbook.laptopservice. Okay, let's try this. We just need to restart Nginx and run make client TLS. Now we can see only login request goes to server 1 and all other create laptop requests go to server 2. Even if we run this make client TLS multiple times. So it works. And that wraps up our lecture about load balancing gRPC with Nginx. I'm going to push this Nginx config file to the PCBook repository so that you can download and play with it if you like. Thanks a lot for watching and following the course. Happy coding and see you in the next videos.